All right, let's do some inequalities with absolute values. So there are a few things to learn, and there's just no shortcut, or there aren't that many shortcuts anyway. If you try to do things too fast, it's a lot easier to get a wrong answer very quickly, but that's not the point. It's inequalities or with absolute values are just, they're a little bit annoying, and there's kind of if it were any simpler, it would be wrong. So you have to do the simplest thing that's still a legal move, and that's, you have to actually do a few things. But what's all the important information? Well, let's just start with one concrete example, and the general case is going to be very similar. So maybe this one I'll do in maybe I'll use the green for this. So what does it mean for absolute value of x be equal to 5? Well, that means there's two ways for that. It means that it's either, if it's already positive, the absolute value just gives you 5. Absolute value of 5 is 5, and absolute value of minus 5 is 5. So it just plus or minus the absolute value removes the minus sign if there is one. So that's just two individual points on the number line. But now we want to look at inequalities. So what kind of happens is absolute value of x equals 5. There's like these two endpoints, and because absolute value function, it's not too crazy. The places where you have equality are here, and then the inequalities, the places where you have equality are the endpoints, and then in between, it's all going to be one or the other. So absolute value of x looks like this. So absolute value of x starts out at 0 when x is 0. And then it gets bigger, and then it's exactly, absolute value of x is exactly 5. Then absolute value of x gets that's what I meant to say. So absolute value of x gets bigger. Absolute value of x gets bigger. So what am I saying here? So absolute value of x is less than 5. Only happens for x's that are close to 0. But there's two ways that the absolute value can be large. You have absolute value is large because large negatives take the absolute value and you get a positive again. So that's what happens. So large negative number, take the absolute value of that, you get a large positive. So take absolute value of 100, you get something that's bigger than 5. Take absolute value of negative 70. The negative 70 is less than minus 5, which means that positive 70 is bigger than positive 5. So it looks like this. So here's kind of a summary of how you do it algebraically. If we're looking at this picture, it's either one or the other. You have equality. So with equality, absolute value equals a if and only if x is plus or minus a. So if the absolute value is 2, then x is plus or minus 2. So in this picture that we drew before, sort of in green, absolute value is less than 5. That means x is between positive 5 and negative 5, which we write as a single inequality. X is bigger than negative 5, or we write negative 5 is less than x, which is also less than 5. X is in between those two. And we write that as a single line. And this last one, people don't like it very much, but there's no shortcut. So what does it mean for absolute value to be large? It's not the intersection of two inequalities. It's not, x is not in between. There's two mutually exclusive ones that are extreme opposites. So what is absolute value of x being large is the same as, it's not a single interval around the origin, it's the extreme opposite of that. So absolute value of x absolute value of x greater than 5 means there's two ways for that to happen. And if it's embedded in a larger problem, like if you had if x was like 5z plus 7 and you had to solve for z as a follow-up, then your work is sort of, you have to keep working. Whatever those two expressions are, absolute value of x is bigger than 5 when x is bigger than 5, but it's also true when x is less than negative 5. So we'll do a few of those. And side remark, there aren't that many like this in the book, I don't think. I want to come back to that at the end, maybe. It's sort of, there is a mathematically correct answer, but it's something very easy to overlook and get stuck on. So just in case you see it in the future, you can start thinking about it right now, but I'll come back to it later. You can pause and even if you want to think about it by yourself. So when is the absolute value of x going to be less than negative 2? When is the absolute value of x going to be equal to negative 2? When is the absolute value of x going to be greater than negative 2? That's something you might want to puzzle over. So the answer might be, it might be an interval, or it might just be like always, or it might be never. It could be the empty set, could be the entire real line. So it's something to think about. But anyways, let's just jump into the problems. These aren't too bad. Maybe I talked too much, I don't know. But anyways, let's just do it. So how do we use these and how do we graph it? We just want absolute value of x is equal to 3. So let's just speed run this one. This is just an equals sign. That just means x equals plus or minus 3. So as a set, I want a solution set that's a finite set of just 2 points, because it's not an inequality, it's the equality. X, absolute value of x is equal to 3, x is plus or minus 3. There's nothing to shade in here, because anything that's in between, it's not equal, it's less than, or it's greater than. But at those 2 points, those are the endpoints. So that's all for that one. This one shouldn't be too much worse, but let's be a little bit careful about this. There's a couple ways you could do this. The most common solution would be just use this. Well, we're not quite done yet. There's a plus or minus, but dividing by 3 on both sides, there's no ambiguity there. It's just nothing weird. You know, positive 2 divided by 3 is 2/3. Negative 2 divided by 3 is negative 2/3. So those two equations, nothing too weird happens. So you can just say negative 2/3 comma positive 2/3 is the solution set. And then the number line, so you have negative 2/3 just those 2 points. Solution number 2 is, this is a little bit fancy, but absolute value of A times B is just absolute value of A times absolute value of B, because either the whole thing's already positive or you just cancel out the minus signs. Whatever you do, you just cancel out all the minus signs. And if I just don't like absolute values too much, I can distribute the absolute value and cancel a few things, and then I have something smaller that's easier to work with. So that's something you can do with multiplication. With addition, you can't really do it. I didn't have to do it this way, so sure, absolute value of x is 2/3, x is plus or minus 2/3. And yep, get all of the same stuff. So I just found some other problem. You can't really do anything with this at all. There's nothing. If you have absolute value of x plus y or x minus y, all these are almost never true. There's just, like, if x and y are both 0 or something silly like that, sometimes it's true, but it's almost never true. You know. Well, this one might be true if x and y are both positive and the absolute value doesn't do anything, for example. But it's not a useful thing to assume, because it's just usually, it's not true when you want it to be true, and then it just doesn't help you. It's just, there's no reason why it should always be true. So don't count on that. It's just not a thing. Multiplication. That's totally fine. All right, so what's next? So number 6. Number 6 is maybe yeah, there's one thing to watch out for, and that is, that one's kind of not really in standard form. What we said on the other side of the dry erase board was, what happens when absolute value of x is less than something, or what happens when absolute value of x is greater than something. But minus absolute value of x, that's a whole other thing. We don't want it in that format. So we can take care of it. So what do we do? So on the other side of the board, we said that if absolute value of x is less than a, then that means one thing. If absolute value of x is greater than a, then that means something else. But we don't have either of those. We have this. None of these said directly, what does it mean when for negative absolute x to be greater than or less than something. None of these said, what does it mean for 1 minus absolute x to be greater than or less than something. But we can add the absolute value of x to both sides, and now we've had to get this all by itself. And so now, sure, now we have something good, but we've written it kind of backwards. The only thing that we get from this is that absolute x is on the small side of the inequality, so I can flip it around, but I have to change the greater than sign to 1 is greater than absolute x, means absolute x is less than 1. So just put x on the small side of the inequality. Now that's kind of, usually it's written this way. These mean the same thing, but we're used to writing absolute x on the left-hand side. And then we ask ourselves, now just sort of by visual memory, absolute x is less than something. That means it means this one. It's the single interval from that's in the middle. So x. So this is it's not an ordered pair. It's an interval. This is interval notation for a collection of x's. And on a number line, it looks like this. We exclude the endpoints because it's a strict inequality. X is not allowed to be, absolute x is not allowed to be equal to 1. It has to be strictly less. And that'll do it right there. All right, so number 7. We're going to need a little bit more space because the absolute value has already been isolated, but there's a greater than or equal to. So we have to be careful with that. So these are a little bit annoying, a little bit weird, but we can do it. The greater than or equal to's are a little bit annoying. But I didn't mean to write that down. I meant to write down something like, I don't know, it's just 5. I definitely didn't mean to say 0. I wanted to keep this one kind of standard. Okay, so okay, so unfortunately, it's not a single inequality. It's not like a chain of inequalities because technically, you don't. This kind of problem for absolute x less than 2. That's the kind of thing you can write down because you're saying that both of those things are true. But here we're saying only one of those two things, and there's no way that they can both be true at the same time. You can't be bigger than 5 and also be less than -5. There's this or statement. Most of the steps are exactly the same because they have in common, they have what's the expression in 3x minus 1. So we're going to do the same steps, but in 2 different things. So we add 1 to both sides, and we get -4 for this one. Divide by 3. It's positive, so stop and think, okay, wait, that I'm dividing by a positive number, so the inequality stays the same. Divide by +3, x is and x is bigger than or equal to 2 equals, okay, and we're including equals, so square, here's 2, we go all the way out to infinity, keep going, and then x is less than or equal to, or so including -4/3, go all the way out to minus infinity, shade all that in. And how do we write this in interval notation? interval notation is a little bit cumbersome, but as a solution set, we have these two things that are completely separate from each other, but there's two ways that the absolute value can be. You can get a big negative number or a big positive number. So, square bracket. So x goes from minus infinity up to and including -4/3. And then the other way of doing it is the other piece of the solution set. So the interval notation for the solution set looks like this. Sketching the number line is kind of, the reason why they encourage sketching the number line is that it doesn't matter which order you start writing it down in. You just draw a picture, you shade in part of the number line. Oh, that happens to be the piece on the right in hindsight. But then you keep drawing. You draw the other piece of the number line. And in hindsight, that's this piece to the left here. And then once you have a picture, going from that picture to interval notation is not too bad. You've got two different pieces that don't overlap whatsoever, and together that gives you a solution set. Okay, so so that's kind of it for that one. Let's see, was there anything else? No, let's just keep going. Okay, so that was number 7. 8 and 9 should be a little bit faster now. Let's just so as far as number 6 was a little bit interesting. That's kind of but the rest of this one is kind of a little bit more. The only algebra that you do before using the basic fact is, well, do I have the absolute value isolated on the left-hand side of the inequality and with nothing on the outside of it whatsoever? Then I can use the fundamental fact is that how do I rewrite absolute values less than a number? That means less than is the one that's nice. That means it's less than that, but it's greater than the negative. So here, I guess that's negative 1.1, and here's positive. I'm subtracting 1 from each side. So here's negative 10/10, so negative 9/10, negative 0.9. And so x is less than negative 0.9 and x is greater than negative 1.1, and it's doing both of those simultaneously. So answer in interval notation looks like that. Okay, so number 9. Let's do 9. Doesn't quite dry up immediately. Okay, so multiplying or dividing, I could distribute the absolute value and then simplify at first, but there's no advantage or disadvantage here. I do have an absolute value of something is less than 4, so whatever's inside the absolute value, I either set it, depending on whether it's less than or greater than, then it's just two inequalities that are either true separately or simultaneously. So less than is the simultaneously. 2x minus 1 is bigger than minus 4, but it's also less than positive 4. So multiply by positive 3. So I can't emphasize this enough. I'm multiplying by positive 3, so the inequality does not flip. Add 1 to both sides, I get negative 11. It's less than 2x, it's less than positive 13. I did this. Okay, yeah. So x is bigger than negative 5.5, but x is less than, divide 13 by 2, you get 6.5. So interval notation or sketch on a number line. So the solution interval looks like that. Okay, so there was one quick sorry. So here's a statement. What's the solution set for that? If a is a negative number, you probably shouldn't see this too often. Just if you're taking a class where the instructor is really a fan of these, like checking to see if you're aware kind of situations. You never ever want to say that the absolute value is less than a negative number. That never happens. Absolute value is never equal to a negative number. So, for example, when is the absolute value of x less than negative 2? Well, the absolute value of x is never less than negative 2. So, and then if I want to solve, when is absolute value of x greater than negative 1? Well, that's always, always, always. You can plug in negative 5 trillion, or you can plug in 0. You can plug in anything. Whatever number you pick, the absolute value is always bigger than negative 1. But the absolute value of x is never, ever, ever less than negative 2. So just wanted to throw that in there. I didn't see any MyLab problems that were about that. But I mean, it's like it is a reasonable question. It's just, you do all this work on the, on the absolute value less than positive number, absolute value greater than positive number. You do a lot of work. There's this whole process. There's a lot of steps. Well, here there aren't any steps. It's just you just look at that and you immediately know it's never ever ever, or it's always always always. So it's kind of, you have to have a lot of awareness of the situation, and then the answer is immediately without any further computation. But you have to be on your toes to catch it. And it's just that kind of problem. So it's all this process with mathematics to solve the ones where it's absolute values. When is that absolute value greater than or less than get a certain given positive number? That's very interesting. There's a lot of work you have to do. But for a negative number, absolute value is never less than negative number. It's always greater. It's never equal. So so it's something like -13. Never, never. Oh wait, it's always that one though. Okay. I think that's it. I've repeated myself a lot. Hope that makes sense. I only did one of these. If you're still having problems, you can look at some of the examples in the book. I think the book does a pretty good job with these. That's what I recommend. But there's also the tutors, or maybe you can send a short email. I hope that this makes a lot of sense if you sort of just watch the examples. Yeah, that's it.